If I was to share that another way, I'll just put a Post-it over the top of it. Say cross-canceling is something you're not familiar with, or your student was like, what? We haven't done that yet. 2/5 of 3/4. They might just multiply straight across the top and get 6/20, which could be reduced to the same thing, 3/10 again. So there's that same answer. And by the way, of course, this is what we want students to be able to do, just to work purely with numbers, but students still need to be able to work it out as an area model. So over here on this side, I'm going to draw a rectangle. It should be similar size and shape. Students may be asked sometimes to use rulers, or maybe not, depending on their abilities, but they should work to try to make something that looks like this, not drawing things like this. That's not at all what we want going on a sheet. We want students trying to be neat. So 2/5 of 3/4. I would just take the first one and put it on the first side over like this, and the second one and put it on the top side, so 3/4 like that. 2/5 means we're going to be dividing this dimension here into fifths. Again, use that trick of putting a finger in the middle, and then from that, kind of drawing what you think might be the size of one space. And if you've got 1, and you need 2 and 2 to make 5, so you're just cutting each of those in half, and it's easier visually to cut things in half than to cut things in odd groups. The top is 3/4, which isn't as tough. We're going to first look at, it's an even number, so we're going to cut this into even pieces, 2 and 2, and we're going to take half of each of those, and that's pretty easy visually to do. And we've got we've got fourths on that side. So you can pretty much see right now that the 20ths that is made here, each one of these is a 20th of the space, because you've got 5 by 4 of them. So here, that's when people teach, well, you multiply straight across and you don't know where those numbers come from. That's how the 20 is represented, by an array that's shaped like this. 2/5, the students need to go 1, 2, 3, 4, 5, and they're going to shade 2 out of those 5. So that means they are going to go all the way across, because we're starting on this dimension and this dimension, and they have to go all the way across. They want to be reasonably neat. There's 2/5, and they take another color, and this side's 3/4. And again, we're going to be looking at the area that's overlapping. That's going to be the answer to the problem, or the product. 3/4. So we're going to shade this way. Here's 1/4. Here's 2/4, because we're looking at 1, 2, 3 out of the 4. So 3/4 like this. And then you've got one space here of overlap, 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 overlap. And you can see that that's 1, 2, 3, 4, 5, 6 out of the total 20 spaces. So there's the 6/20. And then reducing it means you would be basically making these larger. So 3/10. This would, if I were to, students don't need to go this far, but just in case you're curious, this is 1/10. This is 2/10. This is 3/10. And what I'm doing is I'm just combining in groups of 2s. So I would go across and I would get down here and I would have 8/10. But of course, this area, these two sitting next to each other, would be the same areas stacked on top of each other. And so if we're looking at areas, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's where the 3/10 is a reduction of the 6/20. So anyway, that's how to use an area model to represent the multiplication of two fractions.